Active matter has been used in various applications like molecular shuttles. To bring the application to the next level, we need to develop the ability to control the active matter locally. We provide an easy-to-use method that doesn't require modification of the active fluid, nor the need to modify the optical path of microscope to achieve the local control of the active fluid. Our method can be applied to a wide range of systems where the main reactions obey the Arrhenius law, such as the microtubule gliding assay or enzyme-based systems.
The setup involves a water circulation system. If leaks occur, water can damage the microscope. Therefore, before adopting our protocol, it is important to ensure the system is leak-free. Our protocol requires mounting the glass sample on a temperature stage. While the manuscript describes the mounting procedure, it lacks mechanical subtleties, such as securing the sample to the stage.
Demonstrating the procedure will be Teagan Bate, Edward Jarvis, and Megan Varney. Teagan and Edward are graduate students, and Megan is an undergraduate student from my laboratory.
To prepare active fluids in an Eppendorf tube, mix 16.7 microliters of 8 milligrams per milliliter microtubules with 6.7 microliters of 1.8 micromolar kinesin motor clusters and 1.1 microliters of 500 millimolar DTT in high salt M2B. Bundle microtubules